Second recording for the day. All right, so characters and strings. And we're just going to talk about characters today. So the last of our 8 primitive types, right? So we had the 6 numeric types last week, and oh no, this is the 7th of the 8. We haven't covered Booleans. I covered Booleans today in JavaScript. So char is the 7th of the 8. What fundamentally it is a number that prints as text. Okay, so like a short, a char is a 16-bit integer that allows 65,000 and change possibilities. And there's a whole bunch of different character sets that you can access through Java's char set class, but we're going to use the basic standard one. Okay, so as you can imagine, since say English has 26 different letters, 65,000 characters can encompass a lot of different languages, okay, or at least ones that use letters and letters and numbers, and then the variety of oddball symbols. But of course, they have ones for more pictographic languages like say Chinese, Japanese, Korean, that sort of thing. Okay. Anyway, so because a char is a number, it can do addition, can do other arithmetic operations, right? So you can add characters together. For example, if you want to convert a letter from uppercase to lowercase, you can do that by adding 32 to the uppercase value. And you can do comparisons. So normally, if I ask you, is R less than Q? You would say, that doesn't even make sense. That the question's entire premise is faulty, right? How do you order the letters? Well, in Java, because chars are fundamentally numbers, yes, you can sort them. Now, of course, you could come up with a scheme for sorting letters, but you just couldn't do it as numbers. So in Java, you can do comparisons, which is obviously useful for things like alphabetization and other types of sorting. So when you're writing it, it gets signified as one character in single quotes. If you're, for example, doing a literal string like this, system.out.println A, that'll print out the character A. And we could do that in our, we'll make a class here, fun with chars. Okay. So system.out.println A. Okay. Likewise, system.out.println numbers, lowercase letters start at 97. So if I do 98, that's B. So if I say typecast 98 to a char, that's going to be a lowercase b. Okay, and then what else? I can do math on it. System.out.println char 98 plus 1. Okay, so I'll get ABC. Oh yeah, prints out the 9. Did that wrong. I got to do it as a string. Whoop. Sorry, this concatenation. I'm not on my best today. All right, we'll just do it that way. Fine. All right, we run into some troubles. I just leave that. So what it is, a character, this, you'll see this is, I put in the note. So this is a literal char. Is a number, but prints as text. Okay. This here, this is also a number typecast to a char, prints as text. Okay. When I'm doing this here, I'm going to undo this. If I did this, right, here I'm combining string, because that empty pair of quotes, that's what's called an empty string. Combining string and char prints as text. Okay, so if I run this, ta-da, ABC, right? Likewise, I can always convert, I can have some other operations. I can do something like char D equals what, 99? No, 100. Okay. So D is there, and I could do system.out.println D. Okay, which again, this is just a char, non-literal char. Of course, prints as text. So ABCD. There we go. And then the last one, I can do some math on it. So the question is D plus a number, right? D plus 1, is that going to be an int, or is that going to be a char? Let's see. That one prints as a number. Okay, even if I put it in here, the fact that this is a number, it's going to convert to a char. I mean, it's going to convert to an int because this is a mixed expression. Even if I do something like byte, let's see what happens there. Same thing, right? I would have to do this. I would have to say D plus char 1. If I do that, and they're both chars, it still wants to treat it as a number. Okay, even a char plus a char. So this is very confusing. Okay, I would have to do this to make this actually work. I would say this is going to be a char, and I get to give it my extra parenthesis. Oh, where's I have an extra one here? Oh, there's my extra one. Okay, there we go. Can finally do that. Okay, so typecast expression to char will work. Okay, but as you can see, characters are numbers, chars are numbers, but they behave strangely. Until you get used to them, they're a little unpredictable. Okay, so the best thing to do best way to handle chars is to keep them simple. Okay, only print out the exact char that you need, and avoid doing math inside print statements, print method calls. Okay, so that's the best advice I can give you. Otherwise, like I said, you get some weird stuff there. But if you do have a char, it will print as a letter, not as a number. But if you do some other manipulations on it, like we've seen, it can very easily turn back into a number. Okay, so a couple more slides here, and then we'll call it a day. So remember, fundamentally, char is a number. So you can typecast to and from a char and any other numeric types, and that's fine. But you can't typecast from a char to a string because string is an object. It's not a primitive. You cannot typecast a char to a string. What you can do, if you want to convert a character to a single character string, you can do things like concatenation. That's where we use the plus symbol to add together text strings. We'll talk more about that on Wednesday. And there are primitive classes. We'll talk more about those too. There are various ways that you can automatically convert characters or other numeric variables to strings and vice versa. Okay, so syntax, char variable declared the same way as other numeric primitives, so just char C. Then the IDE will know that C is some variable of type char. You can assign it in two ways. You can assign it either as a number or other expression, or you can assign it as a literal character. So C here is 65. 65 is the character code encoding for a capital A. So in both of these cases, C would hold the number 65. But if you tried to print C, it would print as a capital A. You can also do mathematical operations. This works with, English language character set. So the capital letters start at 65. You can add 32 to convert them to lowercase. Likewise, the lowercase letters start at 97. Subtract 32 to bring it back to uppercase. Okay, and that's it. So that's the quick thing about chars. I don't have a whole lot to say about them. Strings we end up using a lot more, but that's okay. This is a good break point. So that worked out nicely. Questions on characters. I'm going to stop the sharing for a moment. Questions on characters? So again, key takeaways on characters. Okay, number one, they are numbers that print as text. You can do math on them, but then they stop being chars and become some standard numeric type. Okay, and the reason is this. I'll tell you the reason why. Any numeric primitive, even a byte, can hold negative numbers, but char can't. Okay, char is from 0 to 65,535, 2 to the 16th minus 1. Okay, no negatives. Thus, any numeric primitive could hold a value that's not legal for a char. Okay, so unless you do typecasting, so unless you typecast the number to a char, Java will avoid treating the number as a char. So that's what goes on there. Okay, basically, if you do some math on a character and you don't specifically typecast it into a char afterward, it's going to stop being a char. And the reason is because all these numbers, they can have negative values, and negative values, when a char tries to read a negative value from the character set, things are going to get really wrong fast. Okay, so it's not a valid number to have. I mean, we could go to the IDE for briefly. I just do the whole screen. Okay, if I do something like char c equals -1, right? I get an error for that. It's going to say type mismatch, cannot convert from int to char. It's not a valid thing. It's not going to let me do it. It says, sorry, Charlie, not today. Okay, so that's where I'm going to stop recording. If people have questions, I am happy to stay and discuss, but this concludes our brief introduction to characters. We'll have